All right, what's up, everybody? We're back doing another problem. Um, this one, not sure if it's on LinkedIn, Leetcode. Um, I was going to I'm kind of just following my friend's what do you call it? Um, interview preparation thing, and so if he says it's not on LinkedIn, I'm just gonna LinkedIn Leetcode. Oh my god, obsessed with LinkedIn for some reason, I guess. Um, if he says it's not on Leetcode, then I'm just gonna trust him with that. If 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 you're actually find the problem and you're like you're wrong, then yeah, feel free to let me know. I will address that. I can update it. Uh, I can make like a follow up video or just make a comment saying like, hey, it actually does work. Um, so yeah. Um, so I guess without further ado, we'll get into the problem doing it this way because not on Leetcode, right? So yeah. Given m sorted arrays, find the kth smallest number among all the arrays. Pretty simple, right? So we have three arrays here. The first array with 2, 6, 8. Second array with 3, 6, 7. And the third array with 1, 3, 4. We want the fifth smallest number. So if we look, we have a 1, 2, 3, 3, and 4. So our fifth smallest number will be 4. Or I guess like I could have just looked at this, right? We have 1, 2, 3, 3, 4. So the fifth smallest number is 4. I think it's pretty self-explanatory, so we can just get into doing the solution. So from heap q, we want to import star again because I'm too lazy to type everything out. Yeah. We're going to define a min heap, which is, just defined as a list, but then with heap q, we manipulate it in a different way. For I in range of, what is it? The length of lists. So we have our list here, right? So for I in the range of length of lists, we want to heap push onto our min heap a tuple. What's in the tuple, the first item will be list I 0, because that's the first number. We're going to push on the number 0, which will let us know which index we are currently at in the array. And then we'll have I, which will tell us at which index the list that we're currently at, we're looking at, it is in. I will tell us where the list that we are looking at, like where it resides in lists. That makes sense. I hope that did. I think it makes sense. But yeah. Actually, wait. I guess before we keep going, we'll just put our answers real fast, right? So this one we know is 4. This one, the third number, 1, 5, 7. So our smallest number, or our third smallest number is 7. So when we, later on print our values, we should see 4 and 7. Okay. Okay. So now back to the code. So now we just need to pop off k minus 1 numbers, and then I guess we need to pop off k, but then on the kth number we want to return. On k minus 1 we want to keep pushing things back onto the heap, to see if there is stuff to push, right? So while min heap, this will check if the length is greater than 0 or not. If you could also do if length min heap is greater than 0, that works too. We're going to have our number, our current index. Actually, we can call it list index, and we'll have we'll use current index and list index because it's kind of messy, I guess. And then we're gonna heap pop off of the min heap, right? So the number corresponds to this. The current index will respond to whatever index we are currently at in the list, and list index will show us where we are in lists. So hope that wasn't too confusing. Oh, okay, and actually we need another variable that I forgot. We're gonna call it popped off. We're gonna start off at 0. So once popped off has reached k, we know we can return that number, right? So we're going to do popped off plus equals 1. If popped off is equal to k, then we want to return our number, which is right here, right? And then so if we don't return number, then we got to see if we want to push the list back on, because if there's more numbers, we need to push it back on in case, like for example, if we were to do this problem, if we want the 9th smallest number, we would need to go through literally everything, right, until the very last number. So, we got to keep pushing the list back on if there are more numbers available. So, if current index plus 1 is less than the length of list sub list index, since this will show how many numbers we have left in our how many numbers we have in this list, and then if we can go one more over, then we know we have to push it back on, right? So we're going to heap push onto the min heap. We're going to do list index current index plus 1, and we're going to push onto current index plus 1, and we're still going to push on the list index here. Yeah, because the list index doesn't change, right? And we just need to keep moving the current index over by 1, just so we know what number we're looking at. And then this will keep the min heap with the min heap like property. And then here we'll return -1 if we can't find the number. So let's actually make one of those Kth smallest, what is this number? Okay, yeah. Number is actually we should fit what? We should fail this, and then if we go here, string find Kth smallest, we're going to give it just an empty list and the first smallest number, I guess. So yeah, we should get -1 here. We should fail this, as in we should see -1. So yeah, I guess that's just to show that our -1 value would work. Or actually, no. We'll just do this. And then we'll look for the 6th largest number, which should still also be -1. And yeah, so if we were to run it, boop, we get 4, 7, and -1, which is what we expected to see. Yeah, so with that being said, we're done. Yep. Thanks for watching.